Hey guys, Vishal here. In this video, I'm going to show you how to use a push button to blink an LED through a Raspberry Pi. By the end of this video, you'll learn how to use a breadboard, how to connect an LED, how to connect a push button, and also how to write code for the LED and push button on the Raspberry Pi. However, I will not be going over the installation of Raspberry onto the Raspberry Pi or any of the startup procedures. All that is written in a document that I have linked below, so please feel free to check it out. Before we begin, let's take a look at all the items we need. First, we need the Raspberry Pi itself. Then we need the micro USB cable to connect the Pi. Then we need some jumper cables. Then we need a breadboard to make the circuit. We need a push button to control the LED itself, and some resistors. Now, let's take a closer look at each one of these items. Let's start off with the LED. So the LED has two legs, a short one and a long one. The short one is the negative side and the long one is the positive side. The short side is known as a cathode and the long side is known as an anode. Now let's take a look at the breadboard. The breadboard is split up into three different parts, two ground and VDD parts, and then a center connection part. The VDD and the ground rails are connected all the way through horizontally from one end to another end, as shown in this image right here. The connection holes are connected vertically on each side, but they are, however, not connected through the divider between them. Breadboards are great because you don't need to solder your connections in order to make a circuit. All you need is a few jumper wires and you're good to go. And that's why we need jumper wires for this project. Usually to make a circuit on a breadboard, you just need male-to-male jumper wires. But in our case, since we're using a Raspberry Pi, we're going to need some female-to-male jumper wires as well, because the Raspberry Pi has some female headers, and in order to connect to a female header, we need to have a female jumper wire. And to jump that connection onto the breadboard, we need a male jumper wire, and that's why female to male jumper wires are great, because they have a female end and a male end. Now let's move on to the push button. A push button is essentially a switch which you turn on and off through pushing it. So as shown in this image right here, a push button has two sides to it, a AB side and a CD side, and when the push button is not pressed, both the sides are disconnected. When the push button is pressed, the AB side is connected to the CD side, completing the circuit, which turns on the LED. And that is what I'm going to show you in this video. Now let's look at resistors. Resistors are important for this project because we're using an LED and a push button. Every time you use an LED and a push button, it is recommended that you use a resistor, because a LED or a push button might draw a lot more current than the microcontroller can support, and this may fry your board. Last but not least, let's talk about the Raspberry Pi itself. The one I'm using in this video is a 2015 Raspberry Pi Model 3B. It comes with 4 USB 3.0 ports, one Ethernet jack, one 3.5mm headphone jack, a full-size HDMI port, and also a mini USB for powering it. It has 40 GPIO pins, which include 5V VDD pin, a 3.3V VDD pin, and a couple ground pins, and also some input pins and output pins. And that's all we'll need for this project. So let's get started with our circuit. Connect the AC end onto one side of the breadboard and the BD end onto the other, as shown in the image here. Once the push button is securely in place, connect D to ground using a resistor, and connect B to VDD as shown here in the image using a jumper wire. Once you're done connecting the push button, place the positive end of the LED onto the same side as the AC side of the push button and the negative onto the other. Just like how we connected pin D to ground on the push button, connect the negative side of the LED to ground using a resistor. Now let's look at the connections. Before we connect anything to the Pi, make sure that the Pi is disconnected from power and turned off. Now let's start off by connecting our VDD and ground first. Grab one of the jumper wires and plug the female end of the jumper wire to the Raspberry Pi's 5V VDD pin, and connect the male end to one of the VDD rails on the breadboard. On the Raspberry Pi 3B, the VDD pin is the second pin. Now grab another wire and do the same thing for ground. On my Pi, ground is pin number 9. Now connect the positive end of the LED to pin number 7. Similarly, connect pin C of the push button to pin number 11. And just like that, we have made the circuit. Once you're done making the circuit, your circuit should look something like this. Now let's code our Pi. Coding on the Pi is done through the terminal. In order to open the terminal, click on the terminal icon on the toolbar on the top left corner of the desktop. You can code the Pi in many different languages. In this video, I'm going to show you how to code it in Python. In order to do so, we need to open up a text editor. I'm going to be using Nano. In order to open Nano, you're going to have to type in Nano and then the file name. I'll be calling it ledbutton.py. In order to use the GPIO pins, we're going to have to import the libraries for it. So let's start off our code by importing the GPIO library. And also, let's turn off warnings for now since our program is not all that complicated. We'll continue by setting our mode and then setting up our pins. As I mentioned before, 11 pin is going to be reading the push button, so that needs to be set to be an in type. And pin 7 will be controlling the LED, so that needs to be an out type. We want this code to run forever until we stop it, so we're going to put this inside an infinite while loop. First, we'll check if the button has been pressed. If the button has been pressed, it'll send a high signal. So we'll check if pin number 11 is receiving a high signal. If it is, then we need to send a high signal to pin number 7 to turn on the LED. And if pin number 11 is not receiving a high signal, then we just keep the LED off. And that's it. That's our code for this small project. In order to save and exit your code, hit Ctrl Exit. It'll ask you if you want to save. Press Y and then press Enter. In order to run your code, type Python 3 and then your file name and press Enter. As soon as you press Enter, your code should start running, and your code should constantly be printing out button not pressed. That's because we're not pressing the button. As shown in this video here, when the button is pressed, the LED will turn on and your code will print button pressed. And when the button is not pressed, the LED will turn off and your code will print button not pressed. That's it. We have successfully completed our project. In this video, we have learned how to build circuits on a breadboard. We have learned how to connect our circuits to a Raspberry Pi. And we have also learned how to program our circuits on a Raspberry Pi. If you want to learn more about the Raspberry Pi and how to get started with the Raspberry Pi, please feel free to check out the document linked below as mentioned in the beginning of the video. The document walks you through how to format an SD card so that you can put Raspberry on there, how to do the initial setups on the Raspberry Pi, and also a quick walkthrough of what the Pi is and what you would want to use it for. Additionally, the document also has a step-by-step guide on how to build this very same project. So please check it out if you need to. And thank you for watching.